Hello everyone, welcome back to another video. Today we'll be working on some static friction, centripetal force, circular motion, car rounding curve, and rotor ride physics problems. So the first one, what is the maximum speed at which a car can safely round a turn of 90 meters if the coefficient of static friction is 0.75? So here's our car. Here's our turn. Now it has a radius of 90 meters, right? And a coefficient of static friction is 0.75. Now we know the velocity is in this direction, and we want it to turn in this way. So we have to apply a perpendicular force to the velocity. This force here is the friction, right? So since friction is the only force here, we're gonna have the centripetal force, the force of friction, which is directed towards the center of the circle. A static friction in this case equals the mu s times the normal force, which is just mg, since it's not, they didn't say it was a banked curve, it was just a normal flat street, right? So we have Fc equals MAC, right? Which equals mv squared over r, since that's what centripetal acceleration equals. So let's set centripetal acceleration times mass equal to the force of friction. These m's, these masses cancel out, and we're looking for the maximum speed. So v squared over r is equal to the coefficient of static friction times 9.81. Now let's multiply both sides by r, which is 90 meters. Put r here, and let's find the square root, and that will be our velocity. Now, coefficient of static friction was 0.75. So 0.75, 9.81 times 19, which, if we put it in our calculators, will give us 25.7 meters per second. So 25.7 meters per second will be the maximum speed at which a car can safely round a turn of 90 meters if the coefficient of static friction is 0.75. Now, let's calculate the coefficient of static friction. So, our second question. Calculate the coefficient of static friction if a car can round a turn of radius 70 meters at a speed of 24 meters per second. Fix that question mark. So there's a turn, radius is 70 meters. Here's our car, right? Again, centripetal force is going to be equal to the force of static friction. which is mu s times mg. Same case, normal force, flat surface. So the normal force is equal to mg, which equals mv squared over r. Grand turn of, so we know that this is 24 meters per second squared over 70, which equals mu s 9.8. We divide both sides by 9.8 over 9.8. And we canceled out the m's from both sides. So mu s equals 0.84. Thank you guys. Hope you really enjoyed this video a lot, and like and subscribe.